Hello? Yeah, it's working, right? Cool. Um, so yeah, thanks Ganesh. It was nice. And great job to the Platformetry team who have, put up this amazing meetup. And it's actually quite a surprise for me to see so many people on Saturday morning. I didn't expect. I was like, man, mine is the first talk. But yeah, good. So I am Shivji Kumar Jha, and I will be talking about the internals of pub subsystem. The idea is more towards understanding the internals of one streaming system, how it stores messages, how it retrieves messages, and how it manages to, serve you really fast if you publish or consume a message, right? And the point behind why I wanted to do this, one is because only when you understand the internals really really well, you can model your application around any messaging system, and it doesn't have to be Apache Pulsar. I chose Apache Pulsar to demonstrate this because that's what I know the best among all the other messaging frameworks. So yeah, let's get started. Quick show of hands. First, the easier one. How many of you have used a messaging or streaming framework in production or even a personal project or something? And I hope there would be a lot of hands because this is a streaming meetup, right? And the more narrow ones. And how many of those are using Apache Kafka? Yeah, that was expected. Okay. Apache Pulsar, anyone? Oh, I have one. Great. Uh, Anybody using nats? Nats.io/nats server? Nobody. Okay. One guy. Oh, awesome. Great. I have some company. Uh, Amazon Kinesis, anyone? Oh, quite a few, like 5 to 7 people at least. Okay. Others? RabbitMQ or anything? Yeah, what do you use? RabbitMQ. Anybody other, anything other than RabbitMQ and one of these? Sorry? Oh, cloud PubSub. Yeah, yeah, correct. Sure. Fine, fine. So the way this talk is modeled, the decks are modeled is I put a lot of pictures. This is actually the smallest slot in which I have presented Pulsar, only 30 minutes. That's what Avinash told me. But later he told me you can take 30 minutes for the talk and 10 minutes for the question answers and stuff like that. So I have some pictures only, and I have the leeway to sort of stretch it or compress it. What I want you to do is, because there are a lot of, there is only, I think, one person who uses Apache Pulsar here. So if there are doubts, I think I have enough time. You can stop me there, a couple of questions here and there. I really want you to go on this journey with me. Just stop me there, ask me a question. If there are too many questions there, maybe I'll sort of continue at the end. I'll stop you there. But I really want you to follow this flow. And if required at the end, I can sort of run through a bit. But feel free to just ask me a question. Okay, so a bit about me very quickly. I am a regular software developer who happens to love open source and distributed data bases as well as streaming systems. I work at Nutanix right now, where I'm a staff engineer and head this group for distributed data stores, including streaming systems, and it's not only Apache Pulsar, there are others, and analytics databases, OLAP systems. Previously, I was part of MySQL replication, where I sort of wrote a lot of code for MySQL, written backend microservices at other places, and been in a couple of data platform teams across organizations. And I've obviously written a lot of code in the MySQL open source code base. And Apache Pulsar also sort of I have computed around 15 patches or so. The team, my team in total has around 25 to 30 contributions to Pulsar. So, what we do basically as a team is that we make data platform where all the Nutanix products can go ahead and just use this and reducing their cognitive overload and sort of using it in the best ways. So these are my social media handles. I'll also leave with them at the end in case you want to get back to me with a question later. You can sort of, I'm pretty much available on LinkedIn. I check messages and stuff, so you can leave me there. You can find me there. This is YouTube handle where I have done some 10 odd Pulsar talks earlier, so all of those are there in more detail, and then the slides are here as well. I'll upload these as well there. So The way I've organized this talk is that, we first do a quick introduction to Apache Pulsar, because I expected that there will be a lot of Apache Kafka users, less Apache Pulsar. And I wanted to introduce very, very quickly, but I can go deeper if there is interest. Some numbers running 4 years in production. It's over 4 years now at Nutanix. But the point is that, because not a lot of people have used it, I think it helps to see a snapshot of my Grafana dashboard from production, right? That gives you more trust. Then if you look at the Pulsar architecture internally, what are the high-level components under the hood, the layers that make these numbers happen, and then ultimately the read and write parts. That's the heart of this talk, where we see how when you publish a message, it goes inside, and how it goes through various hops and gets persisted on disk, and how when you fetch it back, how it comes back again to get you the message on the consumer. So introduction, yeah. Apache Pulsar is a pub sub. If you used Kafka, very, very similar thing, plus a few extra features and stuff, but at the heart of it, Pulsar is similar to Kafka. And this is pretty much where I stopped talking about Kafka. I don't want to do a Kafka versus Pulsar presentation. It's more about internal software messaging system and stuff. But yeah, we can have a chat at the Q&A. You can see that there's a topic in Pulsar box. I hope you can sort of read the slides. A friend I asked to review said, why black background? I was like, man, I'm going to cred, right? So, so you can see the topic, the publisher publishes messages. The messages get stored at the topic. And depending on your choice of retention, you can keep it for longer. You can sort of ask it to erase after you have consumed the messages and stuff like that. And then you can have multiple subscribers, right? Which could either be a streaming use case, or like Kafka, or it could be a queuing use case like RabbitMQ, right? With a little bit of nuances. They do claim that, this is a combination of the Kafka and RabbitMQ use cases that they do. And we've used both the use cases. It sort of works pretty well. So one cluster for both of those is actually a great win for us. The other thing, I think, if you are using an open source thing that you've not really heard of it before, this is something that I thought would really matter to this group. So this is actually quite a popular Apache project. It's a sort of top-level project in Apache. 600 odd contributors on GitHub. The Slack community has 9,800 plus members. Around 1,000 plus orgs using Apache Pulsar, including some of those in Bangalore, like Flipkart uses it, we at Nutanix use it, Intuit uses it. So there are a few. And then sort of, we also have a community around Apache Pulsar. So I founded that community. The first meetup for Apache Pulsar was at Nutanix that I had hosted. It had around 90 folks joining there. So decently popular. Obviously not as popular as Kafka, like no way, right? Yet. And then the other meetup happened just this week in Flipkart. So, and the third can be sort of at another place. And if any of you want to join there saying we want to host a meetup and stuff, I can do that. I didn't want to make this talk about a lot of features and going through each and everything. The idea of this talk is more about internals of our messaging system. So I sort of quickly wanted to put the highlights though in Apache Pulsar. So there are obviously a lot of features. These are some of these things that I absolutely love. I've done separate talks on most of these, which are available on my YouTube playlist from very different conferences. But very quickly going through these, and don't worry if you don't understand this. I don't expect everyone to just understand this if you've not used Apache Pulsar, right? But what we will do is, I'll present the same slide at the end after going through the internals, and at that time, I think you will understand more, and let's, at that time, discuss a lot on these. I really want to make this an engaging session, right? But at this point of time, going through it quickly, it's open source, like your Kafka. Is Apache 2 license. The thing that has just happened with HashiCorp licensing and stuff scares some people already. So Apache 2 license, pretty good. They can't just close it off. Unified streaming and queuing. You have Kafka like streaming, you have RabbitMQ like queuing, both of those in the same cluster. So you don't do both of them. A multi-tenancy looks very simple on the surface, but this is something that we use a lot in Nutanix. Even Flipkart, when I saw their talk, they seem to use a lot of multi-tenancy features. So what you basically do is you have a bunch of topics, you can group them to put them in one namespace. Like think of it like a Kubernetes namespace or something, right? Then if you have a bunch of namespaces, you can put them together under something called a tenant. And why would you actually do this, right? One reason is that we are an enterprise company at Nutanix. For instance, what we do is tenant for me maps to a particular product. That product has its own requirements, which is common to all its microservices and stuff. That I will wire it in at the tenant level, right? Then depending on different use cases, maybe in some use cases they need a lot of consistency, strong consistency. In the other one, very high on availability and being very sort of high throughput system at low cost and something. So at each namespace level within that tenant, I can put some configs, right? So if within one namespace, I have 50 odd topics, I don't have to go change all their configurations if I have to someday, right? I don't have to manage all of that, right? On the topic level, again, you can do all those configs as well. And then within topics, there are partitions like Kafka has. So I think in my knowledge, Kafka has topics and partitions. And beyond that, this has namespaces within which topics lie. And then there are tenants within which there are a lot of namespaces. Built for the cloud. So this was built a little bit later than Kafka. This project, if my memory serves me right, was started at Yahoo. And then this was open sourced. It came to Apache. It was supported by a company called Streamlio. So if you Google around, you find some container Streamlio. That's the reason. Then Streamlio got bought by Splunk. And then some of those guys came out. They said, we don't want to get acquired like that. We want to build it in open source and continue to do that. So there's another company called StreamNative, which now backs it. Then StreamNative also offers Pulsar as a cloud or support if you want. And there is some company called DataStax. If you know that already, they used to offer Cassandra earlier. Now they are also offering Pulsar as a service. It's built for the cloud. I think that's where I diverged a bit. But it was built a little bit later when AWS happens to be very, very popular. So if you look at the constructs of Pulsar, they tie in very, very well to sort of deploying it in a cloud, deploying it on a Kubernetes. In fact, they have the Helm charts and operators and all of those things as well. If you want to deploy it on Kubernetes, and you should. It's good. There's a lot of isolation options. This is something that is actually very, very good for an enterprise company and stuff. You can scale storage separately, not caring too much about compute. You can scale compute separately. Then you can say that, I have a huge cluster. So one of the things that happens with us is I run a lot of things like Apache, Druid, ClickHouse, Postgres and stuff. So like you would see with Postgres, right? What we do is, for every microservice, there will be a dedicated Postgres, right? And then there are a lot of Postgres instances you have to manage. In Pulsar, what we have done is there are a lot of teams using it, a lot of use cases and all, but it's still only one physical cluster within which there are multiple small logical clusters, and then I can sort of tie back saying only these people use this set of nodes inside Pulsar whole thing of nodes and things like that. There's a lot of isolation options. I have actually done a complete dedicated talk on how to isolate workloads using Pulsar, so I'll leave a link for that in the references. Tiered storage is you have some data on your local disk if you're using AWS, maybe on EBS, and let's say you say that beyond around 250 GB or 500 GB, I want you to just put it on S3, and that's something that Pulsar does under the hood. You won't even notice, right? And there are intelligent systems of fetching, pre-fetching extra and stuff like that, which makes it faster. But this is something that just on the Pulsar brokers configuration you set up, and it will keep doing under the hood. Geo-replication is amazing. It's been there since day one, because you can imagine it was built for Yahoo, a huge organization, and they would want strong DR capabilities. So geo-replication works pretty well. And obviously, you have one Pulsar cluster, you have other Pulsar cluster, and they replicate asynchronously to help latency. And that way you can distribute out. Auto load balancing is actually very, very good. So in Pulsar, you will never have one topic becoming a hotspot, because every topic or every partition in that is also broken down into small chunks of segments, and these segments are sort of distributed across the storage tier. So you will never have that situation when one topic has a lot of throughput, so now this guy is a bottleneck, while other topics could be working fine. right? Or one partition is really, really hot, and then it's starting to struggle, or you have to bump up the disk, or IOPS or something. So that you will not have in Pulsar. So I'm not saying it will never happen that the cluster will be stressed, but if the cluster is stressed, it will be stressed across topics, across partitions, and then you add capacity. It's not like sort of individual topics or partitions or namespaces can just sort of, and then this auto load balancing actually works at a lot of different levels. In the interest of time, I didn't cover this, but I have some extra slides in the appendix section because I thought this would be very interesting. This is something that is a strong reason why 4 years ago, when we were starting on our messaging journey, we thought we wanted to try out something other than Kafka. We had used Kafka in the past. And then we sort of found this. We really like this auto load balancing and stuff. So we never have to rebalance shards in a sort of theoretical sense. That is a lot of theory. Just to drive home the point that this guy is also stable. Like, you can have all the fancy features in an infrastructure product, and if you're not stable, or you don't provide very low latency at high throughput, then it just doesn't work, right? So these are actually from my usage. If you look at it, the throughput for last 2 days, I've literally taken this Grafana snapshot. At peak is beyond 150, 170, 175, somewhere around that megabytes per second. So that's the throughput that we throw in at Pulsar, and Pulsar actually handles it pretty well. Like, this is not a huge cluster, right? There are much bigger clusters that are used at Yahoo, for instance, right? And Splunk, right? But this works really easily for us. Okay, so these are some other graphs. Look at the latency one, right? This is something that I wanted to highlight. I took a snapshot of Grafana for last 7 days, and if you look closely, this is a green line. So this is add and P99. So when you publish a message, it is pretty much, except for that one spike beyond 10 milliseconds in the beginning, it's always single-digit milliseconds, right? So I think this drives from the point that this is very fast on publish. Here you look at entry rate. An entry is basically a batch of messages. Like, you would probably know that if you keep throwing a Kafka or a Pulsar kind of a system with individual messages without batching them, the system will start to struggle very quickly. So you basically, you don't have to batch in the application. The client will take care of it. You just push messages and publish messages and consume messages. But your client library will ultimately go ahead, take a bunch of messages, and make an entry. That's what they call it in Pulsar. So this entry, let's say, is around 10 messages in a particular use case. So my peak here is around way beyond 2.5K. So if there are 10 messages, that would translate to what? 25K messages per second, right? Which is sort of decent. And then I wanted to put this graph, success rate. For last 7 days, this is success on add entry as well as read entry. So publish as well as subscribe, and sort of our success rate has been 100 throughout. And this is something that has been there for actually 4 years for us. We haven't had a lot of, no, I wouldn't say 4 years. It's been up for 4 years till now, right? I don't know how to jinx it, but if you look at so this is success of per entry write and read for last 7 days. You see there's no errors, so this is pretty good. Okay. So I'll take a very quick pause. Are there any quick questions before we go to the architecture? I did cover a lot of theory, or I don't see any hands, so I'll go through with the architecture. But if you have any questions, just raise your hand and ask me. So you have your Apache Pulsar cluster, and you have a couple of apps that publish and consume messages from this system. What we will do is we'll go through a quick animation to show what are the layers under the hood that your messages will pass through, and then we will dive in one more layer down later, but this is from the top view. So you have a couple of apps. Now, let's say you set up this whole Pulsar cluster for your org, and then there are a lot of microservices that keep writing and reading. So while there are a lot of layers beneath that you will see coming up, your applications will not know any other system apart from the broker itself. So you give a broker URL, they will publish at that URL via the Pulsar client library, which is in a lot of different languages. We happen to use Java, Python, and Go ones, which are pretty good. Java is the sort of one. Pulsar is written in Java, so the Java client keeps getting updates with the server all the time. The Python and Go one will lag a little bit generally, and then there are others that we don't use. They are out there. So broker URL is all the applications that publish or consume care about. The others don't know of the existence of others. But there are 3 boxes here. Obviously, it's distributed. And these are stateless, by the way. So, I mean, Kubernetes is something that I think a lot of people would love. Again, a quick show of hands. How many of you have used Kubernetes in some capacity? Okay, good, nice. So broker is actually in Apache Pulsar stateless. A very regular Docker container, just run it, it die, if let it die, let it come up. It's not like it's unstable, but we kill it sometimes here and there. We've just done a lot of crash scenarios, and it sort of performed quite well. Works pretty well with Kubernetes, like I said. It's built for the cloud era. So brokers are stateless, but then they have to form a group for some things. This is not for messaging and stuff, but for some things they need to sort of form this notion of leaders and sort of followers and stuff. Not the primary broker use case of publish, subscribe and stuff, but still for their coordination, consensus, metadata management, leader election, and all of those things, it uses Apache Zookeeper. So if you're setting up Pulsar, you will see that you will have to set up Apache Zookeeper as well, like it used to happen with Kafka. I don't know if the KRAF thing is already operational right now. It is? Okay. Yeah, so the same Zookeeper thing. And Pulsar has always tried to be modular, right? So they are not going the route that Kafka right now is going with KRAF and one executable and stuff, which is also amazing, by the way. I like that in certain use cases. I said broker is stateless, right? So it doesn't really store messages, right? In fact, the disk SSDs that we put for broker are really tiny, like because there's no message, there's some logs and stuff, that's it, nothing else. So where is the data? The data is actually in Bookkeeper. This is a separate Apache project, pretty stable, good, also used in some other use cases, like you will see other companies using this separately from Pulsar. Bookkeeper is actually a system that I am very surprised it's not very popular. What Bookkeeper does is it gives you an infinite log, and if you think of a write-ahead log or something in Postgres or MySQL binary log or something. So that kind of a construct where you put your binary log or write-ahead log, but it's an infinite log, and a log that is sort of divided into very small logical parts. So there are a lot of physical files. Among them, on top of those, there are something called ledgers. These are logical constructs. So there are a lot of configurations and stuff like that you can do. And these ledgers, like segments in any segment-oriented system, are distributed across. So this is a really great system that Pulsar uses quite deeply. So a lot of PMC members in Apache Pulsar you will see are also PMC in Bookkeeper and Zookeeper project management committees. So broker, like I said, right, you'll see the 2 yellow arrows. Broker uses Bookkeeper for data storage. That's the file where all the messages are being written. And you see, if you look at it closely, the 2 arrows that we saw actually go to 2 different Bookkeeper nodes there, right? So Bookkeeper is actually example of a system which does very little, but it does it very, very well, right? So Bookkeeper actually doesn't know that I have to put a replication factor of 2 or 3. So in Pulsar, for instance, you can say on topic or group of topics namespace level, whether for this topic or this bunch of topics, you want a replication factor of 2 or 3 or 5 on the topic level or partition level. No, I don't think partition level, topic level or namespace level. This broker guy will have an SDK, like Java client of Bookkeeper. There you specify that I want to write it at 2 places. The client will, from here, this thread will go and talk to 2 bookkeepers and write 2 separate copies, right? So Bookkeeper is actually not doing replication. It's like 2 requests on 2 different nodes coming and sort of writing that same entry, batch of messages, on two different bookkeepers. And bookkeepers, again, you see that yellow arrow at the bottom there. Bookkeepers also, for their consensus, metadata management, leader election, and stuff like that, use Zookeeper. Like I said, Bookkeeper is for retaining the data. Zookeeper is for coordination. And Pulsar, because this is where the notion of topic comes. This guy doesn't know that there's something called a topic. A topic is a list of ledgers for this guy, right? And sort of indirectly, this is a topic for this guy is a bunch of physical files on disk called entry log files, right? But Pulsar will obviously, some of the, depending on the RAM size you give it and the cache you allowed to keep, it'll cache some of the latest data in the topics, right? And that is why you see that the latency for publish and latency for consume will be very, very small. For writes, it has to write to Bookkeeper anyway. But then it'll keep a cache, so it can sort of fan out and distribute to a lot of other consumers. So I think that's it here. But I'll actually, I have some time, so I'll stop here again. Any questions, please feel free. Yeah, please. Do you have a question? No? Okay. Yeah.
How does this Apache Pulsar behaves in non-cloud ecosystem?
Non-cloud, do you mean a data center?
A regular, wherever I'm not using any AWS, just on-prem servers.
Yes. So we've done, so we are actually on that journey where we want to take some products that were built for cloud and ship it to some on-prem people. We have done a POC on this, but I have not run it in sort of proper production environment in data center yet, but it should work. To be very frank, in the on-prem case, a lot of places, if you really want a distributed modular system and stuff, if the on-prem is under your control, I think then you can use this pretty well. What happens to Nutanix is, Nutanix is an enterprise that builds on-prem for other people. So an HDFC, an Apollo, a Wells Fargo, and American Express, all these guys, their data centers are built ground up from hardware to hypervisor to software, everything from Nutanix. So in those use cases, I think I prefer, my personal opinion is that I prefer to have something that would be a single executable, not too many components. Like you see here, there are at least 9 components, right? So if the on-prem data center is under you, you have all the access, this should work pretty well. The point is, if you have a Kubernetes cluster running in your on-prem, do you have one? Yes, this should work. You have the Helm charts and operators, and there are 2 versions of operators, one from Stream Native, the company that backs this. There's other company called DataStax, they also have Kubernetes operator. You can use one of them.
Thank you.
Yeah.
So basically, when you replicate data in multiple bookkeeper nodes, so don't you need some kind of transaction semantics? Like you failed to replicate among 2 nodes out of 3.
Okay.
Something like that.
So I'll cover that. That's a very good question going ahead in one of the diagrams. But to explain that very quickly, what happens is, let's say I have a bunch of 5 bookkeeper nodes, and when I take a topic, define a topic, I say that I want to have 3 replicas for every message on this topic. So the system will go and out of that 5 nodes, go and select 3 nodes, right? Saying this topic is going to write to these 3 nodes for this point of time, right? One of those could crash, and then out of the other 2 that they were not used, now will come. And Zookeeper will keep a mapping of which bunch of messages were on which 3 nodes and others and stuff like that. Now, what you can also do is, this is a system where you need low latency, high throughput as well, right? So what this allows you to do is, you can say that I need to write it in 3 places, but I am also fine having only 2 acts and stuff like that. Or you can say, if you are very strong about consistency, you can say I will push 3 messages, but I will also expect 3 acts. Only after that you say that I have committed your message and it is written, right?
Depending on the consistency level, you make it either asynchronous or synchronous.
So you don't make it asynchronous. What you can do is, you can say that, hey, go and write only to the memory of these 2 nodes and come back, and it will asynchronously flush depending on OS cache, OS flush interval. Or you can say write to disk and so many disks and then come back. You typically don't write a message asynchronously, right?
The application I was talking about, that the flush part you stored, that depends on the consistency level, the guarantee which the client needs.
So this doesn't have a consistency level like a Postgres or something, right? Different consistency levels that you can just, like an enum you can put there. What this does allow you to do is choose your application factor, how many places do you want to write, and how many places you want to wait, how many of them have to act back. That is a configuration that you can do. And again, at topic level, at group of topic or group of namespaces level, everything is right. So it's like that. But then I think what you are actually essentially asking for is, if I write a publish, I want a guarantee that it's taken by the system and it will be there forever, right? So we haven't faced a problem with this in 4 years of running this in production. And our configurations are write it to 3 places in most of the cases, right? Unless for some specific case, write it to 3 places, give me 2x back, and it's okay. It will go and get this message, right? I've not included those slides. I have another set of slides where I have those things. The talk for that, explaining all of that, is there in my YouTube. So if you really want to go more internal there, I'll share that in the reference section, or you can ping me on LinkedIn and I'll send you those details, right? But yeah, there were other questions. I still have 15 minutes, so I can take a couple more maybe. Yeah, sure. And there is one at the back who didn't get the mic. He was the first to raise. Yeah, so I'll take his, and 2 from here, and then we'll probably take at the end. So 3 questions. Yeah.
Yeah. So when you say any event-driven architecture to use Pulsar as an open source, will have a data quality issues and data corruption issues as well. How you handle it?
Data quality, like exactly, can you be more specific?
Data duplications.
You can set up deduplication logic configurations. But yeah, I mean, in a distributed.
It costs you compute, right?
Sorry?
It costs you compute.
It will.
So have you done it into your first layer itself?
How do you?
Have you done into your first layer of doing it, right? It's, let's say, like if I'm using into a medallion architecture and key Pulsar, and underneath the hood of it, I have a data which is gonna be resides, and it's changing depending upon the access of it. And the deduplication is a one factor when I use it, Pulsar, right? It's not effective because the version control with the brokers, consumer client has to be the similar one. So how you handle the data quality and data corruption issues? Do you have done any automation framework into the first layer of it? I know the later stage you done the enrichment of the data on top of it.
No. So when I talked of deduplication, I talked of on the broker you can set up saying I want to so first of all, in a distributed
schema level you are doing it?
On the topic level.
Okay,
On the broker level.
On a broker level of the topic of the schema.
Yes.
But still that doesn't solve the problem.
Right.
Real-time problem.
Yeah, I agree. So, so in my setup, what we do is we consider this like other distributed systems as write at least once, right? And that's where you're coming from, right? So that's how we use it. Write at least once is fine for us. But yeah, there are deduplication features. There are transactions, right? These are some things that you can use over the top of my head. But I have to think a bit more, I think, on that.
When you see transaction written at once, it's some of the 3 types which we do it, right? It has to be transaction, has to be read once, or if it's not written, it's gonna recheck one more time. But the problem what I'm saying it here, when you're getting an event from outside, so some of the ones which you subscribe it for your application, and you don't have a control on your vendor side. You might have a 3 ways saying right to subscribe them. Deliver at once, deliver guarantee.
Exactly once.
Yeah, exactly once,
yes.
right? So they might send you the different one. How effectively we do our event streaming. So how you are doing in a layer 1. So with the minimum compute, that's what I'm looking.
Okay. So I know of deduplication that you can put on the broker, right? So this is sort of where it will get deduplicated, and the sort of exactly one semantics, there is a nice blog. I've frankly not used that setup in my case, because you are fine with at least once. You will never lose message. That's the guarantee that this guy gives in the default setting. For that, you will have to turn on deduplication. Then there is sort of some other couple of things. I can
that is not going to be event streaming one. When you done in the first layer of your deduplication, you have to store the data.
Yes.
And it might take a 5 minutes of one. It isn't.
Yes.
It's called a near real time, not a real time.
So now, are you saying that the deduplication will only happen across a window of time and not infinite, or?
Let's take like deduplication. One event comes me with a payload of the JSON, and it comes today, and tomorrow with the same one, but you map it with your uniqueness. Either it's a message ID, something inside your payload of the event. So the message ID is gonna be changes, right? And it comes into the different time. After 24 hours or 7 days of it. So even if you say like write it once with your payload, if the similar event, which I get it after 1 or 2 days. So some of the IoT devices which got upgraded and they send a similar duplicate message. So when you say like the first layer itself, you are saying it like to do it, you have to store the data.
Right. When I say the first layer, your interaction is with the first layer, but this will obviously write internally to this, otherwise this is not durable at all, right? And you're right. Deduplication, typically the use cases that I have seen people doing, like the deduplication window, the farther you stretch, the more compute it is going to, or more dollars it is going to sort of add up to. So yeah, I mean, I typically don't see a lot of people putting deduplication windows which are in days. It's typically sort of minutes or maybe stretching to hours. Beyond that, you're right, you will have that problem. Like, I don't think this guy goes solving that problem where your message comes 1 or 2 days later, and then this goes, unless your window is that far. I've not really seen those use cases, so I don't know. But I think this will not do that.
Okay.
This will not do that, yeah.
Yeah, I had a question regarding Zookeeper.
Yes, sir.
So Kafka got rid of it. I have nothing against Zookeeper.
No,
I use it myself as a log provider.
Yeah.
So, but Kafka got rid of it due to a reason, the system maintenance overhead aside, but there were some performance limitations as well, pulling up all the metadata. So is there any discussion within the Pulsar community to have some alternative of Zookeeper, some different raft-based protocol for metadata, quorum metadata? Is there any discussion within the community?
So these guys are actually going the other way. They really like the modularity. What they are doing is, they sort of used to use only Zookeeper, right? You can't use another system. Now they built an interface here and here, and they sort of put this behind that interface. They are going that route where they are saying you can use an etcd kind of a system to also sort of take care of consensus there. What they have also done is, sort of the organization that backs this, called Stream Native, they have written a sort of system which is similar to Zookeeper and which is supposed to perform better for these use cases. It's called, I don't remember the exact name, but it's written by the CTO of Pulsar called Matthew, right? So I can, if you can contact me on LinkedIn, I can send you the sort of exact thing. But it's pretty new, right? This whole system that is built to replace Zookeeper in Pulsar, that's new. And you're right. I mean, Zookeeper is a lovely system, works great for what it is supposed to do. But beyond a 5 GB of data or something, I think it starts to struggle, right? There are also problems like a lot of systems, when they use Zookeeper, they put a lot of data here, or are sort of accessing certain things in ways that Zookeeper is not very good at. So to remove those, they have written that. They say that, with that system, so Pulsar, by the way, says with Zookeeper itself, can support million topics, right? And then they have written this other thing saying there are a bunch of other problems, and expecting to go beyond 1 million and stuff. They can support using that system, but that's not battle tested now. That's just sort of released, I think, 2 or 3 months ago. So they are sort of, from what I see in the community, they are going to stick with this modeler and they're going to keep Zookeeper or a similar system. They're not going to get rid of it. Yes.
And one last question about topic cache. Is that topic cache local to the broker?
Yes. Yes.
So it's local to the broker,
Yes.
fine. But how does, let's say one broker goes down, right? When a new leader is elected via
There's no leader. This is stateless in that sense. But yeah, go ahead.
But there
Yeah.
should be some controller broker
Yes. So
here,
basically,
right?
basically, one topic it's actually in support of your earlier premise of if.
Yeah.
Here it's like one topic is owned by only one broker at one point of time. So the problem is more exaggerated, right? So yeah, go ahead.
Oh, okay. So then,
If it goes down,
yeah. Okay, your topic cache is finally persisted within a bookkeeper.
Yes.
Okay, fine.
Yes. I'll go internals. Those will be very clear. In the interest of time, I have only 5 minutes. So I'll sort of go through quickly. Can I stretch with 5 minutes? 5 minutes. Sure. Oh, 5 minutes is my allotted time, man. Oh, not beyond that. Okay, fine. But I'll go. So there is one more layer within that. I think then these questions will be sort of more clear. But the YouTube lesson, I don't have the slides, contents and stuff, sir. But I'll send you a blog if you can sort of contact me on LinkedIn. Yeah, no problem. So the heart of the talk, I only have 5 minutes, unfortunately. But I'll go through one more level of internal, 2 levels actually. So this is how a message is actually written, right? So there's the client, which is probably your microservice. You write a message to a topic. This is number 1. Then it goes to the broker. Like I said, this is the owner of topic X. No other broker is the owner of topic X, like you said, sir. And then this guy is saying, I want to have 3 copies of it, right? And then let's say I'm collecting all the 3x. I am fine with at least 2x, or I can take 3x if I am sort of, my use case favors that. Out of the 5 bookkeepers, 3 bookkeepers are selected, and if one goes, I can take up this, and Zookeeper will maintain that state and stuff, right? So in these 3 brokers, I go and write this message that I had sent. And I'll skip this detail in the interest of time. And if you look at this one line, right? So if we zoom in there, that's what I present next. So you have the bookkeeper, the top 3 boxes, right? That guy has a bookkeeper Java client inside that, right? It also has a topic cache, right? On the top, it writes to the bookkeeper system. So the 3 boxes in the middle, right? Where we write data. There's something called journal in bookkeeper. Journal is like your write-ahead log again. It's a very small file where only writes happen. There are no reads that happen from journal, right? And this is like multiple different topics, all there, published and everything, just being dumped very, very quickly, right? And sort of one after the other. So, and then you form a bunch of journal files. Then there are sort of entries written within each of these files. One of them fills up. Zookeeper comes in, gets one more file, keeps the metadata and stuff like that. And then you say ledger 1, entry 1, ledger 2, ledger 1, entry 2. And this is like a snapshot of this. So let's say the orange one is a different topic, this one is a different topic, and the yellow one is a different topic. So all these are interleaved, kept together. And then you maintain a write cache, right? Where you keep keep things in the ordered way. This is in memory when you are writing. And the reason is, and this yellow arrow is synchronous. So when you're writing, you write to the cache, and then you write all the way, write cache, journal, and you get back. That's what happens within one bookkeeper, right? At a later time, the green arrows are asynchronous. So at a later time, the system goes and takes the write cache and dumps that to something called ledger, which is where the reads will go to, right? Apart from a bit, so some cache layers, it will come to this at the end. Read path, right? So you say that I want to read a topic. You can sort of go to the exact topic, or you may land up on some other topic. So this topic, every broker, you may land up on another broker as well. This is a distributed system, right? You will land up anywhere when you start at least. And then every broker has a lookup routine which will tell you that, hey, you should go to this broker because he's your owner. So you will be redirected there, and then the TCP collection will carry on sort of for longer, where you sort of just keep talking to the right owner broker. So if the topic is held by this broker, it will read from cache and just return. So that is obviously very fast in memory in broker. If it is not there and there is a cache miss, then that is why cold reads obviously in any messaging systems are a little bit more expensive, more latency. So this has to now go to one of the bookkeepers. If that bookkeeper has crashed or something, then this sort of guy knows. He's the one through the bookkeeper client who maintains the sort of replication, and the replication information will be stored in Zookeeper ultimately. So from there he will get another copy, another bookkeeper where it can sort of fire and then get the data. Right? So I said journal we will just go write very, very quickly. In the write cache we will sort of keep it, but at a later time everything will be flushed in batches to something called ledgers. Now when I read my application that is having the sort of Pulsar client, the sort of Java, Go, Python, whatever, Pulsar client, that application says I want to read. So it will come to the broker cache. If it is there and there is a hit, then you just return. If it is not there in the broker cache, then you go, there is something called a read cache. This is number 2. So the bookkeeper system maintains a read cache. So we saw the write cache. It will be maintained for a smaller time with the sort of journal one-on-one. And then sort of when we flush back, we don't only flush to sort of the ledger system. Ledger also has something accompanying it called read cache, right? So if you just sort of miss the broker cache, you come to the read cache of bookkeeper. There again, everything is order in memory, you get it quickly. If here also you have a miss, then you go to the ledger disk. Ledger disk is basically a wrapper on top of RocksDB, right? Every bookkeeper system, bookkeeper is nothing, but every bookkeeper system is individual, standalone, doesn't know much about other bookkeepers. Everyone is a RocksDB under the hood, right? And a Zookeeper along all these systems to tie them together, make a cluster. So if you miss the read cache, then you come here, and this is the index. Think of it as a mem table, and the SS tables are here. So you come to this index, find the exact offset saying which file in this sort of ledger sequence sequence of ledger files, which file and exactly which offset, and then you get that message. It's actually a batch. You get that batch, and around that messages and everything you get along with it, and you can sort of, the client on the consumer side in the app will reopen that and give you the exact messages. Right? I don't think I have enough time to cover these again, but I do have, so I'll very quickly show you that I'll share the slide again after the talk with Avinash, and I'll put it on my LinkedIn as well. So you'll get the slides. These are the references that I talked of. These are sort of, this is the Apache Pulsar Slack and user mailing list, dev mailing list and stuff. That's QR code for my LinkedIn profile. I was hopeful I'll have some questions, but if there are questions after that, and I'm happy I had some of them, but if you have more questions, that's my LinkedIn. QR code, you can just scan and connect with me. Okay. And then these are my social media handles where you'll find other talks and slides. Do I have a couple of minutes to take questions or no, wrap up? Sure, sure. So if there are more questions, I'll stay on after the talk, or I'll be there for the whole meetup. You can catch me up or hit me up on LinkedIn with whatever question you have, or if you want more details, I can share a blog or video or something, right? But yeah, that's it. So I'll wrap this up. Yeah.